GCC, this will be our last video for chapter 13. We have 3 more problems we're going to bang out for stoichiometry. So my first one, you need to write a reaction. So we have HCl gas plus oxygen gas produces chlorine gas and water vapor. I want you to pause and write this reaction for me. Okay, I hope you gave it a try. We got HCl gas plus, I hope you remembered oxygen is O2 because it's diatomic, then the arrow. And then chlorine gas is also diatomic, so Cl2 gas. And then H2O gas because it says vapor, right? H2O gas. And then we balance it and we get 4 HCl gases plus oxygen gas makes 2 chlorine gases, Cl2 gas, plus 2 H2O gas. I hope you were able to write and balance that reaction from chapter 10, because that's not going away. So make sure you can write and balance reactions from chapter 10. All right, here's our question. How many liters of chlorine, it's a chemical, can be formed if 3.00 liters of oxygen react, oxygen, another chemical, react completely at STP? So we got 2 chemicals in a balanced reaction at stoichiometry. I hope you know by now stoichiometry means you need a mole ratio. Let's start with what we're given. 3.00 liters of oxygen, O2. That's what we're going to start with. Liters is not moles. We can't do a mole ratio, so we have to go from liters to moles. How do you go from liters to moles? It's right here on the back of your table. There's 22.4 liters in a mole at STP, and we are at STP. So we've got 1 mole of oxygen over 22.4 liters of oxygen. Liters cancel. We got our moles. We're ready for the mole ratio. What mole has to be on bottom? Oxygen, right? Because that's what we started with. So moles of oxygen's on the bottom. How many moles of oxygen are in the balanced reaction? Just 1. So 1 mole of oxygen's on the bottom. What are we finding? Chlorine. We're finding chlorine gas. How many chlorines are in the balanced reaction? I hope you said 2. So 2 moles of chlorine's on top. That's our mole ratio. Liters of oxygen canceled, moles of oxygen canceled. Now we have moles of chlorine, but that's not our answer. What do we want? We want liters of chlorine, not moles. How do you go between moles and liters? 22.4 liters in a mole. So our last setup is 22.4 liters of chlorine over 1 mole of chlorine. Looks like this. There you go. 3.00 liters of oxygen times 1 mole of oxygen over 22.4 liters. Liters cancel. Mole ratio. 2 moles of chlorine over 1 mole of oxygen. Moles of oxygen cancel. Last step, 22.4 liters of, that should be chlorine, over 1 mole of chlorine, should be chlorine. Last step should be chlorine, sorry about that. And we get 6 liters of chlorine. 6 liters of chlorine for that example. All right. Notice the 22.4 is actually canceled out with each other, so the math is actually just 3 times 2 is 6. So, but we got to keep our 3 sig fig, 6.00. All right, last example, last slide. Carbon reacts with oxygen gas to form carbon monoxide. I want you to write that reaction real quick. Hit pause. All right, carbon, is that a solid, liquid, or gas? Carbon. It's right here in this ring, this diamond ring. It's not a gas. Carbon's a solid. Diamonds are solid. Carbon's a solid. It reacts with O2 gas. Hope you remembered oxygen's diatomic. And it's going to form carbon monoxide, which is just CO. And there is our C, 2 C's plus O2 gas makes 2 CO gas. All right, now I want you to work on these 2 questions for me. I want you to pause, read them, and answer them. How many liters of carbon monoxide at STP can be made from? Number 1, 15 grams of carbon. So you're going to start with 15 grams of carbon. and end up with liters of carbon monoxide. And then number 2, 20 liters of oxygen gas, O2, and you're going to end up with liters of carbon monoxide. Okay, so we got a grams to moles to liters question, and then we got a liters to moles to liters question. Again, I want you to try these 2 questions on your own. I want you to hit pause. Really do. Try these. Hit pause. I hope you hit pause. Here's your answers. Again, there's our balanced reaction. 2 carbons plus oxygen, O2 gas, makes 2 CO gases. Number 1, we started with 15 grams of carbon. To go from grams to moles, molar mass, a mole of carbon is 12.01 grams of carbon cancel. Mole ratios next. There are 2 carbon monoxides, 2 moles of carbon monoxide, and there are 2 moles of carbon. It's a 2 to 2 mole ratio. Moles of carbon cancel. And then we're trying to find liters of CO gas. So 22.4 liters of CO over a mole of CO. Moles of CO cancel, we get liters. You punch in the math, it's 28.0 because we need 3 sig figs. Second question. We're starting with 20.0 liters of oxygen gas this time. Look at the bottom. 20.0 liters of oxygen. Well, we're going to use our 22.4 liters in a mole to go to moles. So 1 mole of oxygen is 22.4 liters of oxygen. Liters of oxygen cancel. We're left with moles of oxygen. We're ready for the mole ratio. Moles of oxygen's on the bottom. There's only 1 of them. There's 1 mole of O2. Trying to find CO. There are 2 COs. So 2 moles of CO over 1 mole of O2 is the mole ratio. Moles of oxygen cancel. We're left with moles of CO, but we need liters. How do you go from moles to liters? 22.4. 22.4 liters of CO over a mole of CO. Moles of CO cancel. Look at that. The 22.4s actually cancel out. So it's really just 20 times 2 is 40. 40.0 because we need 3 sig figs. That is your last stoichiometry example. You'll probably want to watch these videos a couple of times to make sure you get stoichiometry, especially if you didn't cover this in class. So stoichiometry, remember, 2 chemicals and a balanced reaction mean you're going to have a mole ratio in there. It's the middle step. Good luck, GCC.